There I am. Hello, everybody. Happy Friday. As you can see, I have a friend today in my little neighborhood, and thank you everybody for being for sticking around and hanging out while we were sorting our demos. Uh, if you don't know who this person is, you haven't been listening to the stream very long because he's been a fixture on BreakSec, the audio podcast, and we've had him on the stream a couple of times. I'm having Jay Beale on. Jay, thanks for coming and hanging out today.
Hey, thanks a lot. It's nice to be here, Brian.
Yeah. So Jay has been a friend of mine for years. Known him up in the Seattle area. I think we met a couple of times at DerbyCon. Gives excellent talks and has a penchant for Kubernetes, which I will tell you the first thing, I don't know a lot about Kubernetes. I know it's some magic stuff that folks like Jay and Ian Coldwater, create magic and they do things. And so Jay, every year, I think, for the last few years that, DEF CON and Black Hat have been in person minus the pandemic. You've done a class on Kubernetes and also one on like Linux hardening and other things like AppArmor and SE Linux and those kinds of things, which we've also talked about in depth with you on the show. Go search the archives, y'all. So you're giving the Kubernetes training again this year, and wanted to kind of prime the pump and kind of give people a taste of what to expect at the class, right?
Yeah, that would be great.
Yeah.
Yeah, I've been teaching a Linux attack and defense class at Black Hat since like 2001, and eventually
Wow.
Linux really containers came out of a Linux kernel feature and then became really popular, and then we all got into Kubernetes, this way of orchestrating a pile of machines running containers. So
Very
that
nice.
was really a natural place for me to get interested in and eventually also start teaching. So I have a lot of
Very
fun with
cool.
this.
Very nice. Yeah. So the class is happening during Black Hat, which or DEF CON or both.
Yeah, so I do a class every year at Black Hat, just right before the Black Hat conference starts. There's a Black Hat training event,
Okay.
and then during DEF CON, I'm not teaching. During DEF CON, I and some of my coworkers at InGuardians um, put on a Kubernetes capture the flag at DEF CON, and you can come and
Nice.
play in. Instead of being like super competitive, we've aimed it at being more for to be something for people to learn at, and it's a lot of fun. So if you're looking for a puzzle, you should come play with it. One of the things we're doing this year is we're staging two different versions of the CTF at the same time. The one is the competitive, if you want to come in and try to capture flags, earn points, and compete with other teams. But the other is this is a first time thing we're doing. We're basically going to take the previous year's capture the flag, give you the solution key to it, and you can play through it. And that gives you a chance to actually get some experience with a Kubernetes cluster and get some experience attacking a Kubernetes scenario for real, and not just a simple one step, but actually a multi-step attack chain, and to kind of learn a little bit more about Kubernetes attack
Nice.
by virtue of doing that. So
Right on. So
it's really neat.
every time we have you on talking about Kubernetes, there's always been some major changes, major fixes. I think the first time we had you on, namespaces were the new hotness or something like that. Um, in the last year or so, could you maybe give us some idea? Well, I guess we should back up a little bit. For those people who are unaware of Kubernetes, in the they know it's containers, but what makes it so special? What makes it different from things like Docker, LXC, or something like that in terms of, what you do with it?
Yeah, it's a really good question. Um, so Kubernetes, and I've actually, I mean, honestly, I could pop up some slides if you like and kind of give a little intro, or I can just
I
kind
don't
of,
hate that.
yeah. Let me. I'll share my screen in a second. Let me just
Our
get some
our fans
some
like
slides
interaction
put up.
and cool slides. As long as they have memes in them. If they don't have any memes in them, I don't want to see them. I'm just kidding. I'm just
Uh-oh.
kidding.
might have to do something about that.
Playing it
So
straight,
let's
huh?
see.
Okay.
Well, I'm showing you some slides from my black hat trading class. So it's kind of
Oh,
it's a
very
little,
cool.
it should have some we really should put some memes, but I tend to save the memes for talks where, you're
Okay.
trying to do a little more, showmanship or whatever.
Makes sense. Makes
So
sense.
yeah, here, let me share my second monitor. And if you see me
There we
looking
go.
off in the corner or whatever, it means I'm looking at some monitor that's down here.
That's
But
okay.
so Kubernetes, what I like to do is kind of talk about Kubernetes in terms of kind of two things. The first is this thing we call the microservice architecture, where, like back in the day, you'd make a web application, like you'd make like like imagine an e-commerce web app, storefront, and it would be one program. And if you wanted to scale that one program, sure, you'd run three application servers instead of one, and they'd all back end to the same database cluster or whatever. Um, the a downside of that, more than being about resource allocation, was about development. Nowadays we develop things um, a lot faster. And so there's this book I loved a long time ago called The Mythical Man Month, talked about software engineering, and it said often, basically, if you have a team of if you're a team of like you have a team of 10 people and you're like, man, I want them to develop this application faster. You know what? We got a ton of people, we're gonna add a ton of people, at 40 more people. So you got 50 people. And you think, cool, go from 10 to 50, I should get 5 times as fast, right? Except you realize all those people have to all talk to each other. They all have to like coordinate and have all these stand-up meetings. And one of them can be like, hey, I'm stuck right now. I'm blocked while I wait for this other person's code to be finished. And so there's this thing called the microservice architecture. It was made to make software engineering a little easier. And the idea is you take your program, and if you're going to get 50 people, you take your program and you break it up into, say, um, 10 pieces that all have 5 people developing on it. And you make all those pieces separate programs that all talk to each other. And that sounds really complex. And the picture here should show you that it looks really complex. The advantage, though, is that, and this is something that Amazon did. I have, like, when I do my class, I kind of talk about the really famous Jeff Bezos memo that kind of created AWS by saying, listen, going forward, all the software here that we make, it's all going to be API. It all has to communicate with each other only by API. It can't do all kinds of, can't have backdoors in each other, can't read each other's databases. It all has to be API. And
Right.
this is a sample from Google of an e-commerce application broken up this way. So we got people coming from the internet, they hit the front end. The front end is just one, small app. When the front end wants to figure out what things to recommend you buy, it will go and communicate with a different program, the recommendation service. And the people who are working on the recommendation service, they can work on it. The small team, they work on it. They make version 1. And when they make version 1, instead of stopping and waiting for the front end people to catch up, they say, nope, we're going to call that version 1. And we're going to declare a public API for version 1. And we're going to go work on version 2. And while they're working on version 2, the front end people catch up. They're using version 1 of the recommendation service. And so you don't end up having people blocked on each other. You're able to have the meetings that fit that 2 pizza rule, the idea that a meeting or a development team shouldn't be any bigger than what would be fed by 2 pizzas in a meeting.
Mm-hmm.
And but on the flip side, now your programs have this need. You've got 6 copies of the front end running at once, and they're communicating with 3 copies of the recommendation service. And so they need to be able to find the recommendation service. So we're going to come back to that kind of architecture, but I swear this is about Kubernetes. So the other place that Kubernetes kind of comes from is Google. So Google running their data centers, we know they have a lot of computers and they have a lot of programs. Some of those programs are going to run for a long time. Some are just going to run for a fraction of a second. So Google had, how many machines? They had about, we know in 2016, when they released this paper that talked about this, that talked about kind of a precursor to Kubernetes to Borg that they use internally, that they had 2.5 million servers. So they also said, hey, turns out we launched 2 billion containers per week. What does that mean? I know I've said containers, and I'm not even telling you what a container is, but 2 billion times per week, a program needs to be started on a server at Amazon. Sorry, Google. And so Google's got, that means 3,300 times a second, somebody is starting a program. That program, you need something to figure out which of the 2.5 million servers the program should run on. And this is where the Borg comes in, which is what Google uses. And Kubernetes is kind of a fairly feature similar open source version of. So Kubernetes would have to figure out 3,300 times a second, something has to say, out of my 2.5 million servers, which one has room for this program to run? This program has need for this much CPU and this much RAM and these other kind of resources for this kind of scheduling thing. There's one other big thing that comes in here, and that is that we know about Google. So Google's running all these servers, and there are still hard drives around. And
Right.
if we imagine you got 2.5 million servers, and all of them have to say one hard drive, and hard drives failed at a rate of 2% per year, well, that means if you have 2.5 million servers, you're going to be dealing with a drive failure every 9 minutes. So you're starting 3,300 programs a second, and some of them aren't going to finish because the machines they're on are going to crash. Also, those programs might crash. And I don't know about you, but but I expect that anything I'm running at Google is actually going to be highly available. So how
Right.
would you manage? What would you make for this? And so this is basically what Kubernetes does. This is what Borg does at Google. This is my slide. This is what Borg does at Google, and this is what Kubernetes does for all of us. It basically says if you have a bunch of computers and you want to, whether those are virtual machines or physical machines, and you've got programs that you want to run, and you want to do it in a way that can handle, hardware failure, that can handle programs crashing, that can handle this microservice architecture where, you're not going to run one copy of the front end, you're going to run 9 copies of it, and you're going to run 3 copies of recommendation service. And if the recommendation service gets really busy, you might add another copy of it. And if one of those copies crashes, well, then, you'll have fewer ones. You need everything to still work. And you don't want to like, even Google at 2.5 million servers can't afford to just say, we don't have to use the servers that efficiently because we'll just go to 5 million.
Right.
There are You're trying to control cost. You're trying to control like your cloud bill. I don't know if any of you think about that cloud bill problem, but it seems to come up a lot. So Kubernetes basically has these kind of features. So I'm just going to run down this list. You've got bin packing, which is basically just scheduling, figuring out 3,300 times a second. I've got a program. I want it to run on a computer that's got room for it. Which computer should it go on? And can someone go tell that computer to start running the program? I've got self-healing. Like I have, what I'm going to do in general is I don't want to, if I ask for a program to be run, I'm usually going to ask for maybe 2 or 3 copies of it to be run so that if one of them crashes, my program is still available. So when one crashes, ideally, and Kubernetes will do this, I'd like when one crashes for a new one to get started in its place. And if it crashed because one of the machines fell down or its hard drive died or whatever, I'd like the new copy to run on some other machine. And maybe I'd like to say that if things get really busy, I'd like to get more copies of my program, more containers running that are replicas of the same program. And, just when things get busy, but then when things calm back down, say if we're Amazon, like right after Prime Day, I'd like the number of containers I'm using, the number of computers even that I'm using to scale back down. And I want all this to be happening automatically. It's a little bit more. There's the last one that I really want to hit on is this service discovery, load balancing. So when I said like we're going to break our program up into microservices, well, all those microservices have to be able to find each other. And so what Kubernetes does is basically say, okay, all these programs, they just need to know a DNS name for the other programs they're looking for. And that DNS name is going to automatically resolve into an IP address that's going to resolve into a set of other, a set of IP addresses you can use to reach the containers that they're on. And so I don't want to have to run load balancers. I just want a bunch of, Linux IP tables, rules to be able to route that traffic without it really involving, proxying through things. So I
Right.
get all of this kind of stuff out of Kubernetes. And there's one more thing that's really cool. And that is if you want really, really high uptime, and if you want to be able to scale big, and if you want to be able to not have to be using more cloud resources than you meant to, or more computers than you need to, then you want to automate all this. And
Hmm.
so what Kubernetes does is it's declarative. You say, hey, I've got this program and I'd like it to run on at least, say, 3 copies of it, ideally on 3 different computers, in my cluster, whatever, whether that's a bunch of virtual machines in cloud or whatever. Um, and if things get really busy, you should add some more. And if they're not as busy, you should get rid of some. And heck, I might even say I want my cluster, the number of virtual machines I'm using, to be able to expand and then also to contract. So, just because things were busy this hour, 3 hours from now, if things aren't busy, maybe I don't need to run as many virtual machines anymore. And so Kubernetes is going to take care of that. It's going to do that scaling up and down. It's going to do the self-healing. So when things crash, you don't need to have any human get a page. Um, and it's going to figure out what computers to put things on what. And so it's really cool. You end up getting a whole lot of resiliency, and you don't have to be answering pages or what have you. So that's kind of the biggest, that's what it's there for. I basically think of it as a software-defined data center. And
Nice.
how do containers fit into that? Well, the way the containers fit in is I keep saying, I've got a program that I want to run on 3 computers. What I do is I take that program, and a program will have some kind of stuff that needs to be running on the machines it's running on. Like it'll have some dependencies. Those dependencies might be libraries, but even if it's got no dependencies of like libraries, maybe at least needs to read the SSL search files, so that it can, so that it can actually do TLS, or maybe it needs some other files. So what you do, this is really kind of going to the basics, is going back to that Google case. Like Google basically tells the developers, hey, I'm not going to give you the ability to just SSH on any machine you want and run a program. What I'm going to do is tell you, I want you to create effectively like a tarball. I want you to create a file system, just a mini file system, as small as, ideally as small as you can get, but it can be the size of a Linux distribution, but a file system that includes your program and whatever other files it needs. And that file system is basically what we call a container image. And
Right.
then I need you to give me a little bit of configuration, like, hey, in that container image, what's the path to the program I should run? Um, what what configuration parameters should I give that program? And potentially, like, keep it out of the container image so the container image is reusable. Maybe we can make those, you can make those parameters into something that we pass in as extra objects. But basically, you can run a data center by saying, tell me where to get your container image, tell me what other configuration I need to run it, and that'll let me just run this thing on any of these machines I have that I'm going to call Kubernetes nodes, just nodes in my cluster. Um, and by making it, by having this kind of like really clear, like this is kind of infrastructure as code. Like by having this really clear, give me a container image that I can run anywhere, give me the configuration that I need to run it with. I will, Kubernetes is going to do the rest. It's going to figure out what machines to put it on. It's going to scale it up, scale it down, handle it when it crashes, um, uh, and so on. It's going to be able to handle all the DNS. You'll never have to know what your IP address is. You end up getting something that's really, that makes really efficient use of resources, that keeps things far more far more resilient than otherwise. And it means that you have to do a little bit more in terms of your practices, of like some of your DevOps practices. Your goal as much as possible is to make it so that, like, hey, you should expect at any point that the contain that if you give me a container image and I run it and I run 3 copies of it, one of those copies should be capable of failing at any time, and the app should still work. Um, and that means if there's data that's going to come, that if there's data that's being written by your program, it shouldn't be written. It shouldn't be getting written in the container. It should get written somewhere else. As much as possible, you're trying to make it so that those containers that are running are what we'll call ephemeral. And so the really cool thing is you have these ephemeral containers, which means there's no state in them. Um, and you even when you get really good, you have ephemeral nodes in your cluster. So your cluster can be 5 nodes, it can expand to like 15, and then back down to 7. It's all this kind of cattle, not pets. We basically say, you're no longer saying, no longer giving all of your computers these wonderful names from Babylon 5 or whatever your favorite, old sci-fi
Yep.
is. Um, you're just saying like, hey, something's going wrong with that computer. I'm not going to spend 4 hours trying to figure out what's going on with the computer. I just kill the computer, start a new one.
Right.
So
Right.
yeah. So that's kind of that's probably a really easy way to put it.
That's nice. Yeah. And so so the one it was good that you actually reached out to me because I had saw something on Twitter the other day where Ian Coldwater was talking to somebody and they said that if you want to learn Kubernetes, there's a certain you know list of things you need to learn before you can't just jump into the ocean with a cement block called Kubernetes and make it happen. There's a bit of a learning curve. So one of the first ones is learn some Linux, that kind of thing. Learn some of the basics there, and it's like you're not just going to be able to take any application and Kubernetify it, or I don't know if that's even a term or not, but it does take some doing to orchestrate or to convert, your web application into a Kubernetes instance. And, there is a right way to do it. And there's a super wrong way of doing it, obviously. And hopefully you'll be showing us here with some of the CTF stuff or some of the other demos you're doing. But so in your opinion, when Ian was, I don't know if you saw the Twitter thread on this, but what are the prerequisites? Like you need to understand some Linux and you need to understand how your system actually works before you try to Kubernetify it, or can anybody just throw up an environment and drop some nodes on there and then hope for the best?
Yeah, I'm gonna look for the thread. Generally,
Yeah,
if Ian Coldwater says something technical about Kubernetes or Linux, uh, I would bet it's right, hardcore. The What I'd say, I don't know if I can find the tweet that quickly. Although if you can
yeah,
toss me a link,
I was
pull
trying
it
to
up.
find
But
it too, but yeah,
I can guess what it might, I can guess what it might say. And the the thing that I've enjoyed about Kubernetes and containers before that is that I'm a Linux head. I've been into Linux and Linux security for a really long time, and so for me, this was really a natural place to go. But um, it sounds really similar to like when we're all talking to recent college grads or people going into school, or people who are just starting out in IT or whatever, and they say they want to do security, and we're like, wait, if you want to do security, just make sure that you have a good fundamental on good grasp of the fundamentals and how computers work. You don't have to do that by a class, a book, a person,
right.
whatever works for you in terms of your learning style. And that's um, and one of the coolest things about our field is that um, there isn't this strong like, okay, you have to go through the following path to get there, which means that all of us folks who have all kinds of neurodiversity aren't locked out by like, oh gosh, you can't do that unless you go through 4 degrees. Um, so I think what I'd say, because I'm not finding the link that quickly, but what I'd say is my guess is that um, the point was, if you want to have a not if you want to use Kubernetes, you can start using it anytime you like. And
Right.
I think one of the things that Ian is Ian is very focused. I think Ian's really good about inclusivity, about trying to make sure that we don't have much gatekeeping in our field. Um,
Correct.
so my I know I very much imagine that their point was, you know, might have been more about if you want to be a hardcore expert in Kubernetes, you're going to want to make sure you have strong fundamentals in all of these. You, I think in Kubernetes, it can be very, very helpful to have a good feel for a Linux command line. Um, and that doesn't mean you have to memorize anything. There are great like I honestly learned a lot about Linux command line back in the day from like even the there was something called the Linux documentation project, had all these cool how-tos. Um, and I learned from books and stuff, but it was the um but a good understanding of what a Linux computer is doing, just in general, like kind of what's a computer for. And if you're trying to really get into moving your applications into Kubernetes, it can be a question of like, okay, how is the storage going to work? What storage options are
Right.
available? And then you can see how how either Kubernetes in tree or through an add-on might um, might abstract that, might make that something that you configure in, with a whole pile of YAML usually. Um,
Yep.
I think that, what I'll say is, um, whenever I do a class, like when I do a Black Hat class, my Black Hat classes, while they're very, very Kubernetes focused nowadays, they're still also Linux security. So, and that a recent Kubernetes feature that came through is the ability to have a seccomp filter that all your containers run in unless you specify otherwise. And a seccomp filter means out of the system calls that a program can call, like where system calls are basically anytime the program wants the kernel to like open a file or communicate on the network or what have you. The program asks the kernel to do that. You don't always realize you're doing it because you're doing it through libraries or what have you, but through a system call. And so Docker has, thanks to the efforts of Jeff Frizzell a long while back, like 5 years ago or more, Docker has a default seccomp filter, a default list of system calls that are allowed and ones that and by virtue by that, ones that aren't. And Jess Frizzell did all this work, tried tons of programs so that she could get a specific set of a set of system calls that wasn't all of them, but blocked a ton of, blocked some container escapes and would still run kind of basically about any program you'd ever try to run. And so Kubernetes recently made a default system call list, seccomp filter like Docker's, something that you could easily push out to all the nodes. It was actually controversial, I think, in some ways in Kubernetes that wasn't in there to start because Kubernetes was basically orchestrating Docker nodes, and
Right.
Docker had a default filter. But since Kubernetes didn't have a default filter for a while to avoid breaking things, to avoid losing creating breaking changes, they didn't have one. So now they're getting one. What's to bring this back around? The reason this is fun, reason this is kind of fun to me, and there's this, um, it's interesting is those like creating a seccomp filter, using one or making ones that are specific to programs. I have that in my class at Black Hat, but I've had that in the class at Black Hat since before I was teaching Kubernetes in it because it's a Linux feature. And it's the same with AppArmor. Like AppArmor is thanks to Crispin Cohen and a bunch of people
Yeah.
who worked with him. Yeah,
Just saw him the other
out here
night.
near Seattle.
Yeah, I want to get him on the show too because it's it's interesting because he's like, oh, I invented the stack canary, and I'm like, seriously, brah. And so he's like, well, he said he was on the team that helped out with that, but yeah, he's got a patent for stack canary, and I worked with him at Leviathan, and he was my carpool buddy for about a year and a half.
No
So
way. Wow.
yeah, yeah.
Wow. That would be a brilliant. The two of you are really, really smart. It would have been really fun to be in that carpool.
Yeah.
Um,
Yeah.
well, yeah. So
Definitely some
yeah,
interesting discussions. Yeah. Yeah.
but yeah, this is a good example. Like App Armor goes back. I think Crispin and his team created that in 2000. Um, and so like App Armor has been a Linux feature that, is actually a little easier to use in Kubernetes because you can say, I'm going to apply an App Armor profile to a container. I don't have to apply it to a whole computer because like an App Armor is kind of cool and it always was about one program, um, but a ton of what we do in like a bunch of Kubernetes security stuff is around runtime. It's around, is things you would do to Linux process. So it's things you do to Linux process. Next step, you do them in the Linux container. Next step, you orchestrate those Linux containers, having those security profiles, having app armor, seccomp, um, you know, root capability white allow listing,
Yep.
um, and so on. You have that as, these are now things that for Kubernetes to orchestrate. And for you to then say, hey, wait, it's cool. Instead of just saying that I can have an Aperture profile on everything that I run um, with Kubernetes, because you're orchestrating a bunch of computers, you can say anything in my cluster that runs is going to have an Aperture profile. So now I
Right.
get to actually like enforce better security across my software defined data center and end up getting like it's cool. It's really neat.
Yep.
So,
Yep.
um, I think, yeah,
Yep.
that's my guess.
So I found Ian's tweet and I put it in the
Oh,
chat for
oh,
you.
cool.
Um,
Oh, cool. Awesome.
it started out with beginner Kubernetes resources often assume you have a background knowledge of containers, which will often assume you have a background knowledge in Linux. For maximum coherence, I recommend learning Linux, then containers, then container orchestration in that order. Somebody said,
Yeah.
any chance the Linux part is negotiable? And Ian said, well, I'll put it this way: you can try. I would be open to learning Linux things anyway. Yeah,
Yeah.
I somehow yeah, Ian does not gatekeep. So if any of my comments earlier, if
No, no,
anybody thought
no.
that I was feeling like they were gatekeeping, that is not the case. This was
No,
I
not
had
by
read
far.
the tweet and I was like, oh, I remember that because that makes so much sense. Understanding Linux, understanding containers, understanding the orchestration part, because once you've built containers and like you said, there's going to be automation. You have to automate it because it gets tedious after that. You're sitting at a command line all day, and you don't want to do that. So yeah,
Yeah.
Ian's completely right in that it makes sense to understand at least SSH, some basic Linux commands, and then move into the container side of it. So yeah,
Yeah. Yeah. And that tweet is definitely um, the kind of meaning I was expecting. Like it's
yep, yep,
in particular, their reply saying like, you know, no, you can, when someone asked them like, hey, can I do this without, is the Linux part negotiable? Ian said, effectively, like, you can learn this without learning Linux, but I think you might want to learn some Linux. And I
yeah. You
think
might
that
want to,
that's
yeah.
yeah. So it's
It won't hurt your resume to know a little bit of Linux. So yeah,
and it's really fun. And what's crazy is like people who haven't gotten into Linux yet, like it looks really hard. And this is probably true about Kubernetes and and containers too. It all looks really hard. But it's not. It's just another thing to learn. Like if you can, like
right,
and being if you're in IT, um, like the coolest thing about our field is that we get to learn every day. We
yep,
have to basically learn every day. And as a result, we get to. It's like it's built into it's built into all the expectation of what we're doing whenever we do our work. And it's the
yep,
coolest thing.
yep.
So if anybody ever wants me to, I'm happy to give you like a few of the like shortest paths I can think of to like coming up to speed on Linux. It's the cool thing about Linux is actually it seems harder because it's so command line focused, but what's really neat is that that Unix and Linux being built in its image, was created to run on a PDP 11 or a PDP 7, like a really, really, really old computer with very little RAM, very little CPU.
Yep.
Um, and and it still does run on really, really, really low resource computers. Um, and a big part of that is because, in a lot of ways, it's 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 simple. Um, it's just you like it's not necessarily intuitive, but it
Right.
is simple if you can put the time if you can put some of the time in and find the right way of learning for you. Um, like I said, I happen to chew through books. They're really fun for me, but everybody has different things. You'll Nowadays you can find all kinds of YouTube videos and you can find blog posts and all kinds of different ways, and you can get a Linux computer, for DigitalOcean for $5 a month, or any of the cloud
Right.
providers very inexpensively. Just remember to turn it off when you're done. Um, so, but
Exactly. Exactly.
yeah, yeah, cool.
Yeah, very so we've got some background here. We've got, Ian's philosophy on coherence, on how things work. Your class is gonna so your class you teach at Black Hat, is it not to use like the 100, 200 level, but I'm going to anyway. Is it a 100 level? Is it a 200 level? What kind of prerequisites do you need to know Linux to be able to go to class? What
Yeah,
would you be lost if you were like, hey, I don't know Kubernetes, but I'm just here to learn?
yeah, it's a really good question. What I would say is that on the Kubernetes side, um, we started assuming that you don't know anything about Kubernetes, that you've never touched it. We also start out assuming that you haven't ever used containers before. Um, Now we do some training to, do some training like hands-on to, have you create container images, run those containers on a system running Docker, not on a Kubernetes cluster, and and then see how, like, hey, the container image just gets laid out on the file system. It's like unpacking a tarball. This is
Right.
not a um, On the flip side, the place where you want to have some more solid on that prerequisite side is we basically tell people you need to have some comfort with Linux at command line level. Um, if you haven't spent time on Linux command line at all, it's you know everybody's welcome, but it would be harder, and I think it's not really the right first class that way.
Right.
So we're great for Kubernetes. We're great for people who haven't touched Kubernetes before. But if they haven't spent some time with Linux, it would be harder. The
Okay.
I mean, we do the class that all the exercises are basically kind of a, copy paste, see what you're doing so that everyone can move at roughly the same speed through an exercise and we get to cover a lot more. Um, but you want to understand what you're doing. And
Right.
like we end up teaching people a lot more command line cool stuff, just because it's helpful. But you want to be able to kind of read what's happening on that command line and already understand the pieces. Even what might be new is how they're being put together, what they're being used to do.
Right. Understood.
So
Yeah.
yeah,
That makes sense. I mean, you don't want somebody to spend, I would say a fair bit of cash on a class, a Black Hat or something, and then not, come away with it completely lost after the first day. So it makes sense. And you can probably see anybody who might be struggling in the class after a few years of doing this. You're like, you can read that body language pretty quickly, I would imagine. So,
yeah.
um,
There's something else you put in the chat with me, which was this other tweet from somebody else
yeah,
that's
yeah.
really
The
kind of
joke.
like,
Yeah.
it's a joke, but it makes Ian's points really well, where it's like, hey, you know, you've got Linux fundamentals, and then like Linux fundamentals, and then somewhere over that you've got networking cloud, and over that you've got containers, and then Kubernetes is a higher up step. So
Right.
um, it's meant as a joke, where someone's basically trying to reach from the ground floor all the way up to Kubernetes, and then I mean all the way up to containers and Kubernetes. um, without getting that Linux fundamentals. And I think that, yeah, I think it's the joke's well made, and there's a reason it's there. Um, it's, you know, it's kind of, um, doing calculus without arithmetic is, you
Right.
know,
Right. And
yeah,
I think trying to go to the fifth step, like they're saying, if you don't have a foundation, you're going to get discouraged, you'll get confused, you'll get unhappy. You'll be like, oh, Kubernetes sucks. And it doesn't suck. It's just maybe you haven't grokked the other bits that actually help make it work, like the networking portion, or, you're not reading your documentation. And as I mentioned earlier, the question was like, what are some of the developments that have happened in the last year since we've talked with you? It's a fast moving target. And if
yeah.
you once you get plugged into Kubernetes, you have to continue keeping track of things, because it will deprecate things that you're using, or it will get rid of things that or it'll add things that will either make your job easier or harder. And so, you have to really be plugged into the changes that are happening, or the proposed changes that are coming, or what have you, because it is a very fast moving target.
It's a really it's a really good point. It's the um, and it's definitely a faster, because it's still, it's not 10 years old yet. Um, it's a little older than it was when I first got into it, but it's really, um, excuse me, I'm drinking seltzer water. It's making me burp. Um, Um, but it's definitely still developing really fast, and
Right.
things are getting better. And but being on a rapidly and, what's the other word? It's a really healthy level of development.
Hmm.
Um, really, in Kubernetes means you have to keep up. It's kind of a
Yep.
we recently had, in Guardians, we do a lot of Kubernetes pen testing, Kubernetes architecture, Kubernetes architecture review or training or whatever. And we had a client recently, and one of the pieces of advice we gave them was to take some of their folks that had gotten strong with Kubernetes, and let them specialize into that, um, because there's a lot for them to follow, and having to handle a lot of different areas, including it, is makes things a little harder. Um,
Are you trying to
so
turn them all into SREs or something? Is that what you're trying to do? You just,
uh, I don't know what I'm trying to do in
site
that case.
reliability engineer. Yeah.
Yeah, yeah, definitely. The I mean, it's interesting. I think that's one of the interesting things in DevOps has been like kind of um the 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 ways that, operating the machines operating the machines, the cloud environments has become part of engineering, it's become part of development, and
Right.
then specialized back out a little more. Like, it's been kind of fun to watch, and it's interesting. Different companies are trying different things, or different organizations are trying different things. So,
Right.
um, yeah, I think,
Yeah.
yeah. So,
So Kubernetes appears to be fairly complicated. So in my experience, things that are complicated means that it's really easy to hack. Um, I'm sure you've got some demos of things of where people have done things that are wrong. So you've done engagements, obviously, for Kubernetes, and we actually talked before the podcast here about some other things. But some of the things we were talking about was like, you know, trends that you're seeing, or things like, namespace issues, or what have you. Um, is there a list of things that you can rattle off to a company before you do an engagement and see their face go, oh crap, we're not doing that, we're not doing, oh, that's okay, we already know that that's a problem. Are there a laundry list of things when they say, hey, we have a Kubernetes, we're so cool, and it's like, are you doing X, Y, and Z? And you're like, oh, what does it look like when you go in and you evaluate them?
yeah, I think there's, in a lot of ways, there are kind of like checklists, or um there's the, like, these are some of the most important things. Like, honestly, Kubernetes isn't new in that a lot of what you're trying to do isn't isn't that unique in security, and that a lot of what you're trying to do from the perspective of defending it
Right.
um, is to start with authorization. Is to basically say, okay, what people and what non-human, service accounts is what they're called in Kubernetes, but
Right.
what principles are allowed to do what things. And so in Kubernetes, you have RBAC, role-based access control, that basically is a way of organizing who's allowed to, create what resources or edit what, change, edit what resources, delete them, and so on, list them, get information from them. And then on top of that, you have a wider pool of ways to create authorization for, like, okay, well, if you're allowed to create containers on a cluster, um, if you're allowed to create pods that have containers in them on a cluster, like what kind of uh, uh, what kind of rules should we have for the things you create? And I'm looking over at a sticker. I have this sticker on my laptop that Ian Coldwater and Duffy Coley created. Um, it's a little sticker. It's a one-liner that you could run where if you're allowed to create a container, if you're allowed to create a pod
Hmm.
um, on a Kubernetes cluster, if there are no rules, if there's no admission control that says what kind of pod you can create, then it's a one-liner that gives you a container and gives you breakout on whatever node on whatever computer that container lands on. Just a one-liner, and it's a great little sticker, and it even glows now. And I have it right on my laptop. Um, it's a sticker basically from a famous tweet that they made, and that's anyway. So RBAC, like basically first thing in Kubernetes is basically authorization. Who's allowed to create what, and for the things that they're allowed to create, you know, for once they're allowed to create things or modify things or whatever, what are the standards you're going to have? What kind of controls you can have um, about those things that are being created? And there's lots more, but that's kind of the first. That's kind of the first thing you start talking about. Um, Another part of what you get into, again, with that whole like so much of it ends up coming to authorization because that's how you enforce. That's how you enforce, or that's how you like put into the process having some controls. And saying like, okay, I want to have a software bill of materials on everything. Like
Right.
I want to have for any programs, for any containers, for any programs and all of their dependencies that are going to be staged onto my Kubernetes cluster. I'd like to know if any of them have software that's got known security vulnerabilities in it. So can I like both can I make sure that on the way in I'm checking, and then can I actually can I basically check the whole cluster um, on an ongoing basis to make sure that I know, oh wait, hey, there's some of the stuff I'm running has got, has,
Right.
um, you know, has the latest big CVE that gets a cool marketing name.
Right.
So yeah,
um,
so I don't know. There are big. I mean, I don't know. There are big lists. It's kind of hard to figure out a way to nicely summarize. But you end up asking a lot. I think you end up asking a lot about um, uh, what people are doing about runtime security and what people are doing about authorization. Um, you ask. What's cool is a bunch of the stuff that might be that might seem to just be really important for uptime, for reliability, ends up like directly, hitting security. Um,
right.
and that's kind of cool too. Like a lot of this ends up, like I was talking earlier about ephemeral, about this idea um, from a software development and from a maintainability perspective. You say like, hey, I should be able. I love this idea of like Netflix. Netflix had a great one. Had a great name for one. They had Chaos Monkey, right? I should be
Right.
able to go and take any part of the infrastructure and turn it off, or cut a cable, or rip it out, and the infrastructure should still keep going. Like nobody tripping over one cable should be capable of making it so that so that people can no longer stream their Netflix movies. Like it should have to be more complex to cause an outage. Um,
Right.
and so, you know, so anyway, what you do for that ends up being really useful for security. Like one of those is you can say you can say the bulk of the containers in the cluster. have to have read-only file systems. So as that's really useful for making sure that those containers truly won't ever have any state. Like it's a great way, like that feature kind of more than security in a lot of ways is, that or that expectation more than security was made to say, I really, really want to make sure it's all ephemeral because then I know that if one container fails or one node in the cluster fails, everything's still good. Now, on the flip side, as an attacker, I've ended up landing in a container, like there's a vulnerable program, I'm in the container, and I can't change any file I can't change the file system at all. I can't create anything on the file system at all. That is frustrating. It makes your job as an attacker a lot harder. Yeah, this has been the fun thing about my career is that I've been spending my time both on the defense and offense.
Right.
And so like I'll, I can say like, man, yeah, I hate it when the cluster has a whole bunch of read-only containers because as an attacker, I'm like totally frustrated.
Right.
But as a defender, that's totally good news. So,
Exactly. Yeah.
um,
And probably makes it easy to. So, are those kinds of configurations easy to maintain? Or is it very simple to screw something up and then you just completely ruin it? Or, because I'm imagining with orchestration, once you've tweaked your configs to the point where they're as secure as they can be, uh, yeah, we can do that. Give me a second here.
yeah, no problem.
Does the orchestration work in such a way so that it's reproducible every time? So after you've come in and shown them how to harden their system, uh, they're secure afterwards, or is it the version 1.25.5 of Kubernetes comes out and now everything's all up in the air again and you have to resecure everything?
I thought you were going to one place with the question at first, and then you went a different place. So I thought you were saying like, hey, yeah. So if I can ask, if I can make sure I'm understanding your question, I think you're saying like, hey, um, if somebody, if you were to go through and um, and harden the heck out of a Kubernetes cluster, take a look at what needs doing and do it, are you done? Is
Right.
that kind of the question?
Yeah,
Yeah.
I mean, obviously there's if you make a change, you add an application or add a configuration change, you're gonna have to reharden it. But can you create a hardened environment consistently?
Um, yeah, what I want to say is this is like all of computing. You're never done, right?
Okay.
But you're going to make things better. And um, so let me see how to answer this. Um, if you take a system, including a Kubernetes cluster, where you've never done um, where you've never stopped and kind of done a security review, you're going to have a lot more to do the first time. You're going to say, oh my gosh, it turns out that sticker's one-liner works here, right?
Right.
But if you go and you say, okay, I'm going to make it so that sticker's one-liner doesn't work. I'm going to make it so that um, no, I'm going to make it so that with the exception of the parts that are supposed to be for control plane, nothing's allowed to start up a privileged container on the cluster. Um, it's not allowed to use different kinds of. It's not allowed to specify that it wants to be a container that's not that doesn't use the. Sorry, it doesn't. You don't. You say. Um, no one's allowed to have a container that uses the host's IP address or the host's network interface or what have you. Once you put that into place, you don't end up having to do that so much again. There
Okay.
will at some point be some maintenance. You can acquire technical debt. But on the other hand, um, first, you're always going to have to keep getting better and better. And there are parts that can then drift. So like one of the things I was talking about was saying role-based access control. What humans and what service accounts are allowed to do what. So you could go and look for any weaknesses where you say, "Oh wait, oh my God, there's this, there's this pod here. has a container in it, and that container in it is running the simplest thing in here. Maybe it's let's just make it a MySQL database. That MySQL database shouldn't has a service count attached to it. That service count should basically needs to be able to maybe go read an S3 bucket or whatever. But instead, the service count has been given the ability to completely change anything on the cluster, full cluster admin privileges.
Right on.
Well, you can catch that, you can fix it, but going forward, that can happen again. So, you have a couple options. One is you can go, I'm going to go and check for stuff like that, I don't know, once a month or once a quarter. Um, Another is you could create some automation that's going to run and look for that kind of thing regularly, but you're going to have to maintain that automation.
Right on.
Um,
Okay.
that's the hard part. Like there's some stuff where it's like, yes, you can make things stronger and they'll stay strong. And there are others where it's a harder problem. But it's
Right
a
on.
harder problem in the ways, to go back to the idea that Kubernetes in a lot of ways isn't that new. It's a harder problem in the same way that computers already have been. Like, where it's like, hey, on a Linux system, you might find a directory that's, world writable, and that's bad. And so you'll look for that every now and then, and so on. On Windows, you can find out that like, oh, oops, we've made it so that all the people in the marketing department are domain admins. It's like 3 steps away, but they're able to get to domain admin, and we find that by running Bloodhound against the AD, against our Active Directory on a regular basis.
Cool.
Um,
Okay.
but yeah, you'll have stuff where um, and you can choose to either write or buy, I guess, uh, some automation to look for it. But this kind of brings me back I started out a long time ago as a Linux system administrator. Um, we're never truly getting rid of the need to administer systems, or the need to, um, it, we keep saying, oh my gosh, these computers will be so much better that they won't even need humans to operate them or whatever. Or anything that's around long enough is going to need it. Um,
Yep.
although this is the one place that's kind of cool for me. In Kubernetes, we say we want basically all the containers, all the pods to be ephemeral. And then you move up to, hey, if the nodes can be ephemeral, the computer's running it, that's even better. That's like, it's going to let you scale up and down better. It's going to make it's going to make things stronger. The next level up is make the darn clusters ephemeral. If you can
Mm.
take your Kubernetes cluster and instead of maintaining it over 3 years, you're at the point, like that's the next level of DevOps win. Is that if you can say, I'm never going to let the authorization, the role-based access control in this cluster get too crufty, because at any given point, I'm going to be able to kill the cluster off and restart it by starting one script that hits my, Terraform up or whatever that's going to stand up a fresh one. That it's a bunch of effort to get yourself to that level of, I guess rigor might be the word. But once you do it, you get huge wins out of not having out of a whole bunch of kind of problems not being things that can come up as easily,
Okay.
because you're just, you're doing the equivalent of buying a new car every 3 months.
Right.
So you never change the oil because you just bought a new one.
Right on. Okay. I'm gonna vamp for a few minutes. Let you go take a bio break. I've got some stuff I can show while we're doing this, and we'll do the
Cool.
one more demo, and then we'll go.
Okay, cool.
Okay. So while Jay goes and hooks himself up with a bathroom break, Kubernetes.io has some good documentation. Because it's the official Kubernetes site, it should be updated on a regular basis. I say should. This is kubernetes.io/docs/tutorials Kubernetes basics. So talks about some of the structures inside of a cluster that he talked about. You have your nodes, which he talked about as well, like the self-contained VMs, if you will, are a node, or in this case could be a physical computer. Serves as a worker machine for a Kubernetes cluster. You have your control plane, which is it coordinates. It's like a traffic cop or a stoplight intersection that coordinates all your activities. In your application's desired states. It also does scaling and rolling out new updates. So ideally, it will update your nodes if you need them, and bring them up or bring them down, or remove them and put in a newly patched version, that kind of thing. Nodes communicate with the control plane using an API, because everything uses an API in Kubernetes and in clusters and what have you. And one second here, I am learning how to use my cluster, my transitioning bits here. There we go. Kubernetes can be deployed on physical or virtual machines, which is kind of funny because you have virtual with virtual with virtual. Minikube is the lightweight implementation, creates a VM on your local machine. I believe it uses Alpine Linux. I could be wrong there. Alpine Linux is a nice lightweight Linux version. So Minikube. So here's Minikube. Yeah, it runs on Alpine Linux. So that's the version of Alpine Linux you can use if you want to start up a Kubernetes cluster, or you want to use it for Kubernetes. And so available for Linux, Mac OS, and Wow, that was quick. Oh, okay. I was just going through some of the stuff on. I was just going through some of the stuff on Kubernetes.com.
I got back and I was looking at my demos a little bit. Yeah. No, this is good.
And talking about control planes and Kubernetes clusters on the site there. So, all right. Well, we're kind of in the home stretch here. We can always talk about some of the things that we've talked about today with some vulnerable bits. You had a VLC video. I love. I think everybody should be doing videos of their demos before they get to where they need to be. Bloodhound, hello. You're a little late, Bloodbound. Won't lie to you, but we do have this on VOD, and I'll pop this over on YouTube in the next hour or two, and you'll have it available to watch on YouTube as well. They're Bloodbound. So sorry you're late, but you'll have it indefinitely once we get it on YouTube. So this is Jay Beale, Bloodbound. This is there you go.
Hi, Bloodbound.
So let's look at the last demo I think you had queued up, and what we'll do is we'll walk through that and show people some Kubernetes bits that we can partake of that. And Bloodbound didn't miss all the demos, so there you go.
Well, and sometime if you have me back, I'll show folks how they can spin up a quick VM in DigitalOcean and deploy a really cool miniature Kubernetes cluster with Kind, which is Kubernetes in Docker. It's where you could run a multi-node Kubernetes cluster, but the cluster all runs as Docker containers, which means you're able to do a lot. You're able to do a lot with a small amount of resources. Like you could use Kind to comfortably run a Kubernetes cluster on a board like a Raspberry Pi.
Is this one of those yo dog? I hear you like containers, so I put containers in your containers so you can container your containers. Okay.
Yeah, it's like that. Right. Exactly.
Okay.
See, meme away. I like it. Yeah. So anyway, something I'd like to do. A demo I'd like to do is as almost I could do as a teaching thing where you can basically follow along. Let's use Kind, deploy a cluster, do a get pull to pull down a pile of YAML, run a command to then push that YAML onto our cluster and have a quick little mini CTF exercise.
Okay.
And it's kind of cool. Lots of people, I remember I used to tell people, like, I have a Kubernetes cluster running on my laptop, and they'd be like, oh, I don't have a beefy enough laptop for that. I'm like, it doesn't have to be that big. Minikube, what that you brought up is really, really good. The cool thing about Minikube especially is if your machine you're driving is not a Linux machine, if it's a Windows machine or a Mac, Minikube gets you a Linux machine, but it gets you a Linux machine specifically for the purpose of running a cluster that you can then interact with from outside the virtual machine. So it's It's really neat.
Very
Minicube's a
nice.
great tool, and Kind Kubernetes and Docker is also really good. So,
Okay.
yeah,
I
let me
put a
share my
link in
screen. I'll do a
our
quick
I put a link in our video chat for Kind as well. So
rock.
yeah.
Yeah, perfect. Yeah, so uh, yeah, I'm so tempted to like bring up a shell and show you Kind. Um, like I started to actually. Um, the Yeah, it's kind of fun to. I'm not going to do it right now because I really like recorded demos. I like to. So let's stick with the recording because it's nice and
Okay.
easy that way. So what I'm going to do is show you um, one of the exercises we have in the Black Hat class, so you can learn from it right now and kind of see something cool. And we've got this. This uses um, a um, this uses a bunch of YAML that you can use to, you can use on any Kubernetes cluster to create a quick little CTF exercise. And so we'll have to put that on GitHub and put a link in the show notes or in the well, whatever the thing is. Um, Let me just remember how to full screen clearly I'm a little sugar blood low, as it were. Let me just full screen and I'll show you. So this is a recording I've made of just me going through the exercise. In the class we tell someone, we give people an exercise sheet that's in browser and it says, hey, go to this link. And you go to this link and you read a quote from the movie War Games, classic movie from a long time ago. It says, greetings, Professor Falcon, and it ends with, shall we play a game? And you have these buttons. You can click on chess or thermonuclear war or checkers or backgammon. And um, like I said, we have this kind of like, you basically go through and copy and paste what's in here, what's on the exercise side. So someone can choose chess. And what happens is the browser, goes to index.php and says page equals chess. And what's actually happening is that index.php, our web app here that's running inside a Kubernetes cluster, um, uh, uh, um, has a page. The page equals chess. It appends PHP to the end of chess.php, and runs that page. Just happens that page is locally in the container, but we could see if there's a URL. If you could put a URL in instead of chess, that would be a remote file include and run your own code. So here's how we're going to test that. What we're going to do is we're going to stand up left side of the screen. We've got our Kali. This is all done in the Kali Linux system. The left side of the screen, we're going to basically stand up a little simple Python web server. You basically run Python 3 and you say, run me a web server, just serve whatever's in the current directory. So now
Right.
anything that reaches out to our Kali server's IP address, to our Kali machine's IP address on port 8001, will be able to just pull whatever's in this directory. And I'm doing that so it's the simplest way for me to now replace chess with a URL for that web server on port 8001. Recorded me is typing a little slow. So Kali machine's IP address. This is kind of a virtual IP address on the machine in 8001, and I'm going to ask for RFI-likely. And when I ask for RFI hyphen likely on the right side, on the left side, we're seeing the web server logs. We see a GET request for RFI hyphen likely.php. The .php is being added to the end of that chess or to the end of that URL. So what that means is this web app's going to give us remote code execution. It's going to let us run programs in the container as long as those programs are PHP and hosted on our web server. So what we'll do is take that. I'm just going to fast forward a little bit. We're going to go, this is a Kali Linux system. So there's a directory called user share web shells sorted by language. And in there we can find, different things that, we can find web shells, which will just there'll be pages you can put on a web server if it's got the right kind of interpreter that will, one way or another, let us run arbitrary commands. So one of them in here is PHP reverse shell. It's you can read the source. It's on every Kali system. It's created by Pen Test Monkey a long time ago. Oldie but goodie. We take this thing, and instead of modifying the original, copy it into the current directory, and then just change. There's an IP address in that web shell. So this web shell is going to connect back to a netcat listener on whatever IP address we put in here. So the default one is 127.0.1. That won't work for us. We need to put in our Kali system's IP address. We'll do that. And so we've used a little, this sed command just says change this one line. So we've changed our one line. Now we'll set up our netcat listener to listen on port 1234. That's the one that's named in that web shell. And we'll go over to this browser bar and change the RFI likely instead to be the PHP reverse shell, just leaving off the .php at the end. And when we do that,
nice.
over on the left side, we see we've got our netcat listener has now gotten a connection, and it says we're running as this data user.
Right.
And we can look around and do an ls and see there's a flag file. So let's make this fun. Let's take that flag file. Apparently I'm having some trouble typing in this video. I usually edit that out. I'm just going to copy that flag file into the web server that's running in the container. So var.html. I'm just going to copy it into there because then I can go and put that. I can go and look at it in my browser. It's an easy way of like getting the graphic. So 41, and then that funky port 31374. And flag one, and I get to see
Nice.
a little scene from the movie. Now I'm going to show you the defense next. Thank you. Yeah, I'm going to show you the defense next. One thing to notice is this 31374. So whenever we do like a CTF, the hard, one of the parts that has to happen in every scenario is you have to figure out how you're going to put the attacker, or the student, but the attacker inside the cluster. Kubernetes clusters are not very interesting from the outside, unless you find one of the ones that that has an API server accessible to the whole internet, and you find credentials for it. But inside the cluster, it gets really interesting. So we need to put some people in there. We always need an RCE of some sort. And so anyway, but the other part is from outside the cluster, you can't reach anything that's running in it unless somebody actually deploys a way of getting to the cluster. And one of the big ones that's used, even when this is what the load balancers will often connect to, is something called a node port. And you can tell Kubernetes, hey, I need you to listen on some port and forward everything that comes in on that port over to a service that's going to land in some containers. And so those node ports, they start around port like 31,000 or so. It's in the Kubernetes documentation, a well-defined set of port numbers. So that's what we're looking at. Every port in the cluster is listening on 31374. There's 3 nodes in this cluster. They're all listening on 31374, and any traffic that comes into them on 31374, they're sending to just this one container that's on one of the nodes. So that's one way of getting the cluster. The reason I'm bringing it up is that our defense, and I'm going to stop my share for a second and set up the second video, is that our defense is going to say, instead of having these, any part of the list wants to list on the cluster, kind of, having a node port service that sends in, we're going to have all of the external HTTP traffic go through something else called an ingress. And now I'll share my screen. So let me just, good, that's paused over here, share screen. So what we're going to do is we're going to say anything coming in, all this HTTP traffic that comes in, whatever it's coming to, it's going to go through one ingress. And that ingress might still operate as a node port if we want it, but it's going to come through an ingress, and that ingress is going to be a proxy. So there are a bunch of different ingresses, because Kubernetes, one cool thing is that a ton of Kubernetes is meant to be plugin replaceable. You're supposed to be able to like make your own plugins to replace components that are already there, or make your own plugins to add in. So one of the big kinds of, one of those big kinds of things is called an ingress for way to get into the cluster.
Hmm.
And so one of the popular ingresses out there is called Ingress Nginx. It's based on the open source Ingress web server and an HTTP proxy. And the cool thing is that this specific Nginx ingress has been made so that you don't even have to install packages. Just with a little bit of configuration, you can make this thing will operate a web application firewall, a mod security WAF. Mod security is a free open source web application firewall with a rule set that's an OWASP project. And so we just do a little bit of configuration, and we will get for free a WAF for all the incoming traffic from outside. It's going to go to this. It's going to go to that vulnerable application or any other applications we have that might turn out to be vulnerable. So we're going to install it. Installing it's pretty simple. We're using something called Helm. Helm is thought of as a package manager for Kubernetes. It's basically a bunch of, when you want to put something in a Kubernetes cluster, it's generally a bunch of YAML. Could be JSON, but it's generally YAML. And Helm has a bunch of those YAML files, of those manifests that say how to install something, available as effectively as infrastructure as code you can get. So we're going to just say we've installed Helm already on our system. So we're just going to go and tell Helm, hey, add a repository that we're going to call Ingress Nginx. And the actual URL for that repository is on kubernetes.github.io/Ingress Nginx. And once we've added it, we're going to say that we'd like to install something from there. So we'll type Helm show values for Ingress Nginx. For the Ingress Nginx's repo, in that repository, the Ingress Nginx Helm chart. And it tells you a whole bunch of things, of what configuration things you can set. We say show those values. We're going to write them out to a file. Am I paused or unpaused? We're going to write them out to a file. We'll call it Nginx values. Man, my typing here. .orig, so we can make a copy that's not original. We can look at those.
Okay.
And we'll find, okay, this thing right now is set to this Nginx ingress, can listen on a node port for us. So what we're going to do now is basically change the values. Normally when I do VLC, actually, I set playback to go a little faster than normal because clearly my recorded typing is so slow. So we're going to take that, basically going to say that we'd like to install the Ingress Nginx Helm chart. And we're going to tell it to create a Kubernetes namespace for it. And we're going to say that it should get configuration from this file called Nginx values. And in Nginx values, we're just going to basically redefine the one thing we want. We want to say, hey, the Nginx, this ingress should listen on port 32080 for HTTP and 32443 for HTTPS. And that's the only configuration we're going to make.
Right.
So we do that. And now once we've done that, we're going to find that the ingress is running. I can say for that namespace, show me any pods that are running, show me their labels. So I see there's an Ingress Nginx controller. So that's something that's just sitting there making sure that we have that all the incoming traffic is going to an HTTP proxy. I'm writing a little line here that says, hey, wait for that thing to be, wait for whatever pods that are part of that to be ready. These ones are already ready, but I'm just kind of doing this as part of the exercise so that if anything took a while to load, we're not trying to run commands until it's already loaded. So now we'll say, hey, give me a list of services of like internal and external load balancers. And as you say, this thing's going to be listening on port 3280 and sending them in. So we've got a load balancer, this internal service. We'll say, show me the configuration files. So in Kubernetes, I talked about how we were like, you give it, you say, here's my container image, and here's some configuration for how to run that container image, and maybe some extra configuration that I want. Instead of creating files in the image that are specific to an environment or specific to a certain case, I don't put that in the image. I keep the image totally reusable, totally, totally free of configuration, and I push the configuration in otherwise. So Kubernetes has a way of doing that, something called a config map, and that config map, so map is like a dictionary, you know, key value dictionary. And I'm
Right.
going to say, hey, I'm going to create a config map, and that config map's going to be, um, I'm going to look at what the config map was already, and I'll make a change. So I'm going to write that config map out to YAML, and then coolest thing in the world, if you spend any time with JSON, get a tool called JQ. If you spend any time with YAML, get a tool called YQ. YQ is just JQ, but ported to YAML. And what those things will do is let you manipulate JSON or YAML really easily. So we're going to take that and say, hey, I'm telling Kubernetes that config map you just showed me. Cool. I'm going to pipe that out to YQ and tell YQ to add or change a field. In the .data section, I'm going to put one thing. I'm going to put enable mod security is true. And I'll get what's a little hard to see potentially on this color, so sorry about that. I'm gonna write that out to a YAML file. And now, and the reason I'm writing out to a file instead of just throwing it into the cluster, so I have reusable things, and I have reusable YAML I can check into GitHub or source control. So I've got this thing, and I'm gonna add another field that says enable the OWASP mod security core rule set to true. So I'm doing this in multi-steps. I don't have to, because it's a little bit easier to follow and to understand and to do yourself. So created some YAML that basically modifies the config map, modifies the configuration. And once I've done that, I've got mod security. I now have an Nginx ingress controller running, and that ingress controller has a WAF on it, has mod security. Looks like we've done a lot, but we've probably done about 5 or 6 lines of, on our shell. And now I have one more file at that, which is basically say, hey, I want to make it so that when you want to get traffic into Whopper, instead of using that node port we were using earlier, we're going to create a YAML object called an ingress. And that ingress will say, okay, for any traffic that's going to Whopper, it should go through mod security first. I have some lines that are part of the normal mod security configuration. And that ingress is basically, the other part of that ingress is I say, in the spec section, I basically say, I have a rules, anything that comes in with the HTTP host set to Whopper is going to be sent to an internal load balancer called Whopper that already existed on port 80. And so I'm just going to fast forward a little bit. So we have the ingress, it's called Whopper, and with the spec section says that we're using, this is an ingress, the ingress one, there are multiple ingresses, so the one we're going to use is Nginx. And then for Nginx, anything that comes in where the host is Whopper and the path is, well, all of the paths, if the URL is Whopper and then / and then anything, it should all come in. It should all get handled by this ingress, sent to the Whopper pods via their service, via their internal load balancer. And, but it'll have to go through mod security first. So
That's nice. Yeah. That's,
a little bit.
yeah. I heard mod security is going away.
What? No.
No, I thought I'd heard that they're deprecating mod security. So I was like, how is that going to affect people who are using that for like, let me double check.
Yeah, let me take a look.
Maybe it's just the paid product or something.
I would guess that mod security probably won't ever go away, but I can imagine maybe the rule set. Maybe there's a rule set that could.
Let me see.
Maybe the OWASP
history. I remember you were using my deprecation. Let's see here. Yeah, mod security WAF. Well, the F5's Nginx mod security WAF is transitioning. It says due to changes in third-party support for mod security, the mod security version of Nginx for F5 is going to reach. And so, yeah, it sounds like modsecurity.org is not renewing any contracts after the end of service date. Where the hell is it?
For F5.
That's not good.
Mm.
I mean, if Kubernetes requires it, there's probably going to be something new coming out. But
Well, what I remember, let's see, I'm hitting modsecurity.org. I remember, I think it was like Spider Labs was maintaining mod security.
right,
And I can imagine hitting the GitHub page for that to see.
yeah.
So,
Well, I mean, we may
um,
see a mod security bolt-in replacement in Kubernetes within the next year or
sure, or
two.
a
So
fork.
yeah,
I mean, it's interesting. So it was, let's see, development of mod security sponsored by TrustWave. Sponsorship will end July 1. Additional information can be found here. I mean, it's open source. It means if somebody else
right. Somebody will fork it. Yeah.
wants to do some work on it,
Yep.
so um, so it says they'll hand over the maintenance of mod security code back to the open source community.
Oh,
So
okay.
I
Oh,
can
good
probably learn a
then.
little bit more,
Yeah.
but my guess is maybe they'll be looking for a maintainer. Maybe they've already found some maintainers.
Maybe.
But yeah,
Yeah.
that's the way.
Cool.
So I'm gonna throw a link in to this to the Twitch. Oh, apparently I'm
Oh,
not logged into Twitch, so I can't yet. But
that's okay. Add it to the Chime chat or
yeah,
Zoom
I know
chat,
what you're
and
talking
we'll
about.
make it
The
happen.
Zoom. Yeah, find the Zoom chat. I swear it was here just a second ago. I think because I'm sharing my screen, it's in a different place, but I've got a few. Well, hey, let me finish showing you what I'm showing you for a
Yeah.
sec.
Sorry about that.
No worries. So we created we have a Whopper service. That Whopper service is just, how traffic was getting there anyway from the node port. So we got rid of the node port service and we're just
Right.
creating an internal load balancer that the ingress can find its way to. And now we can test. We can do this curl. We use -h to say the host should be Whopper so that we can see what would
Right.
happen if our browser, that was the way DNS worked. Hit any port on the cluster we want. We'll hit the control plane node on the cluster on this port 3280.
Nice.
We get that same Whopper menu. So
Mm-hmm.
now we should make sure, you know, let's see here's my mouse. So now what we should do is try index.php equals, and then page equals our attack, that reverse shell.
Right.
See if that works. When we try, we'll get a 403 forbidden now, whereas before it
Oh.
worked. We should actually make sure that we should, be able to try the other buttons on the page, like whatever your security, you better make sure the thing still works when you're done securing it.
Right.
Hardening something, I should have said. So now let's go and look. I used kubecontrol and asked for a list of pods in this namespace and in the ingresses namespace. We'll take that pod and say, show me the logs. And if I go and look at the logs, I can see the logs on that Nginx, on that ingress Nginx. I'll see mod security. It says access denied with code 403, and it tells me what rule blocked our attack just now. But
Oh,
cool.
cool.
So if our
Nice.
CTF started by getting RCE this way, well, that's now blocked in a whole bunch of other ways of getting, of attacking attacking web apps, or at least this web app that's running on the cluster. Well, if mod security had a rule that's going to block it, it's going to get blocked, which is pretty cool.
Nice. Very nice.
Yeah.
Okay. So we're at time. Sadly, I would like to have you come back. I'm as now that I'm moving back to San Diego and I'm a bit more stable, I do want to bring more content like this on because I'm filthy manager now, so I don't, I don't have access to, I manage talented people who do this stuff all the time. But it doesn't hurt for me to understand it myself. So, um, yeah, I would love to have you back on. We'll talk some more about some Kubernetes stuff. Maybe we can get some more of your. I know we had Tyler Robinson in the past on. You've got a lot of talented people at InGuardians that could probably get involved and hang out as well.
Definitely.
But so I put a link to your class in the stream at one point. Let me go back and grab that. You still have spots available?
Yeah, absolutely. Definitely. Come join the
Okay.
class, and if you need something free, come to DEF CON and try the Kubernetes capture the flag. Also, if you're not coming to DEF CON because of travel or what have you, the Kubernetes capture the flag for DEF CON is going to be available virtually. You don't have to be
Okay.
present. You don't have to be present to win. You have to be present to play.
Very nice.
So,
Okay.
um,
And if people wanted
yeah.
to talk more about Kubernetes, how would they find you?
That's a really good question. So, of course, there's the InGuardians website. I'm going to throw a couple links, but definitely Twitter's a very good resource. Let me just throw a couple things into this. Just checking each one before I paste it. And okay, big pile of pastes, one by one.
Okay.
1, 2, and 3.
All right. I'll
Yeah,
add those. Copy. Yep.
got all
Put
kinds of
that in
cool
there.
resources you'll find on the InGuardians Kubernetes page, including Paraty's Kubernetes pen test tool that we work on, and Bustakube, which is a Kubernetes cluster you can download that has some capture the flag exercises in it.
Very nice. Okay. And then, of course, at Beale on Twitter and at InGuardians on Twitter. All right. And if you're in Vegas, from 5 to 8, whenever the class is going on, Jay's teaching the class. So, I will be there from the 6th through the 9th. So maybe we'll be able to, hang out and I'll get to say hi and I'll try to find you, during the 2 days that I'm there. I'm actually there working, kind of like you are. So, well, not Quody Fingers working. I am literally working an event a couple blocks down the road. So, but yeah, we'll definitely catch up. So, if anybody, yeah. So, like I said, anybody who's chatting, thank you, Bloodbound, for coming and hanging out, and Waltz and everyone else. And yeah, it's the 4th of July week here, weekend, because nobody's going to be working on the 3rd. So we'll get a 4-day weekend for all intents and purposes. Yeah, Jay, thank you so much for coming and hanging out with me today and spending some extra time before the show, just chatting and us
That was
catching
really
up, because
wonderful.
it's been a minute since we've seen one another, so it's good to see you.
Yeah, yeah, it's crazy lately. The time goes by really fast post 2020.
It does, yeah, yeah. So, but hopefully, in my first time in Vegas, it's been your more than once time in Vegas, but it'll be interesting. It'll be interesting to
We'll
see
bet.
all of that, and it'll be good to see you. So,
It'll be good to see you too. Yeah, I hope. Yeah.
right on.
Well, cool.
Cool.
Awesome.
All right. Well, that was it for our show, our stream today, and I'll be back on Tuesday. And otherwise, everyone have a great week, great weekend, a great holiday, and we'll talk to you all very soon. Later, y'all. Bye.
Thanks.